On this video, I'm going to show you how to analyze this circuit using circuit reduction. Okay, these are voltmeters, those are ammeters, so they measure the flow through that. The voltmeters measure the pressure difference or voltage difference across these things. Okay, the first step, if you're using network or circuit reduction, is to reduce it to a solvable circuit if you can. And if you can't, of course, you'll have to use something like Kirchhoff's laws or something like that. Okay, but I can see the 7 and the 11 is going to be an 18, right? Right, and then the 18 and the 13, these guys are connected end to end, so that's parallel. Right? Okay, so that's going to be 13 to the minus 1 plus 18 to the minus 1 to the minus 1, right? The formula we're using there is that R in parallel is 1 over R1 plus 1 over R2. This is just how we type it in our calculator, right? So let's fire up this baby here, right? Okay, so 13 to the minus 1 plus 18 to the minus 1 to the minus 1. I'm going to store that, and this is key, I'm going to store that in A. Okay, and this is 7.548 ohms, and I've stored that in A. Ta-da. Now we've got a 3, a 7.548, and a 5, and it goes through the 3, then this, so that's series. It's not the World Series. But seriously, folks. All right, so that's just simply going to be, this resistance here is going to be simply 3 plus 7.548 plus 5. Okay, so let's do that. Now watch what I type in my calculator. 3 plus alpha A plus 5, storage B. Now you have to go storage alpha B on your TI-83s because they're not as well designed as my TI-86. I love my TI-86. Okay, so this turns out to be 15.548 ohms, and I've stored that in my variable B. Where it be? That's where it be. All right, now let's see. Still can't solve this circuit, but I think I'm close. Okay, this guy and this guy are in parallel, right? This whole mess, and that one resistor is in parallel. So it's like your mind on physics, okay? So that's going to be 17 to the minus 1 plus this guy to the minus 1. The whole thing to the minus 1, right? Okay, so let's do that. Parenthesis. 17 to the minus 1 plus alpha B to the minus 1 to the minus 1. And I'm going to store that in C. Yeah? Okay, let's see. 8.121, I'll just say, ohms. And that's my C. Okay, that's stored in variable C. This is what's stored in B. This is what's stored in A. Now it's solvable. It's a 22.5 with a 8.121 and a 7 in series. It goes through this mess, then through the 7, and then back. So I can solve that. Let's solve that. That one current, A1, is going to be just V over R, right? I is equal to V over R. Okay, so let's see, that's going to be 22.5 divided by this thing, 8.121 plus 7, all in parentheses. Okay, so let's do that. 22.5 divided by parentheses. Well, that 8.121 is just C, right? Alpha C, right? Plus 7. Ta-da. Okay, and I'm going to store that in D just for fun. And that's 1.488 amps is that current, which is the reading on that guy. Okay, that's the current through this guy, that's the current through that, the current leaving the battery. It of course splits up and does crazy stuff over here, but it all comes back together there because current is conserved, right? Charge is conserved, and it goes back to the battery. Okay, now the last thing I got to do is I got to figure out what this voltage is from here to here. This is the reduced part of the circuit. By the way, that's the same as the voltage across this guy. This guy might as well be connected there and there. There's nothing there. This is a conductor. That's all conductor, right? Okay. So V1 is the voltage from point to point of the reduced circuit, right? Okay, that's going to be equal to IR, right? This is our I. This is our R. Okay, so I is 1.488 amps, and the resistance is 8.121 ohms. Okay, so the voltage across the reduced part of this is that number that's on the calculator, right? Which is alpha, what is that, alpha C? Oh, that's alpha D. I gotta write this down, right? Alpha D, right? And then 8.121 is alpha C. It's always good to sort of make sure you're doing the right thing. So this is going to be alpha D times alpha C. Let's store that in E just for fun. It's 12.084. Yeah, there you go. And that's V1. That's the reading on V1. Now, I'm going to stop this video here because otherwise it'll get too long. But in the next video, I'm going to ignore the left side of this circuit, and we're going to look at this part. We're going to pretend that that voltage is across it. Okay, that's going to be the new voltage source, and then we can analyze this circuit here. Okay.